Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. It is February 15th, and this is episode 17 of our weekly live stream. Today we have a special guest, Ian Skerrett. Ian is currently the head of marketing at Flowforge, so we'll get into that later in the program. My name is Dan Gross, and I'm a senior developer advocate at AWS for AWS IoT and FreeRTOS. And I'm joined by my colleagues and co-hosts, Ninad, Alina, and Syed. Hey there, how's it going?
Hey, all good. Super happy to have another episode here. So I'm Nenad. I'm a senior developer advocate for AWS IoT as well. Um, yeah, Lalina, you want to introduce yourself?
Yeah. Hi Dan. Hi everyone. My name is Alina Dima. I'm a senior developer advocate for AWS IoT as well, and I'm working mostly in consumer and connectivity areas. So that's IoT core, device management, and the services around that.
Hi everyone, I'm Syed, and just like my colleagues, I'm a senior developer advocate with AWS IoT, focusing more on security, open source, and functional safety. Over to you, Dan.
Okay, sounds good. Thanks. Okay, with that, let's bring Ian in. Hi, Ian. How you doing today?
Good, Dan. Yourself? Thanks for having me.
Yeah, you bet. Thanks so much for joining. This is really cool. I saw that you were working at Flowforge, and it looked like a really great opportunity to talk more about the company and all the things going on for you in the IoT space.
Sure. No, it's a great opportunity for me, and I've just recently joined Flowforge in January, so it's great to be able to talk about it. And I've been in the IoT world for a while, so I'd love to talk about kind of what I see going on there, and so looking forward to the conversation.
Awesome. Well, let's start. Let's just start a little bit with yeah, maybe your current role at Flowforge, and then maybe a little bit about the company, and then maybe we can get into some of our topics today, which I think includes Node-RED, includes IIoT, and includes open source. So
Sure.
yeah, maybe we'll start with an introduction on your role and more about the company.
Yeah. Okay. So I'm the head of marketing at Flowforge. So Flowforge is a relatively new company. It was formed mid last year. And for many people might not have heard of Flowforge, but lots of people have heard of Node-RED. And so Node-RED, so Flowforge is really the company behind Node-RED. Node-RED's a very popular low code development environment, and kind of an open source development environment that's well used in IoT. And Flowforge is a company that's being built up around Node-RED. And really it's about kind of adding the kind of the software development lifecycle functionality around Node-RED. So we call it kind of DevOps for Node-RED. So kind of Node-RED's very good for the individual developer, very productive for the individual developer. It doesn't have a lot of the collaboration features, the software development delivery pipeline features that people really need kind of to do large scale development with Node-RED, and that's really what Flowforge is all about. So as I said, it's a relatively new company. It's a small company. There's 10 of us at Flowforge, but we're getting the word out there and kind of getting really good response to kind of what we're offering. So
that's really exciting. So that's interesting that Flowforge is somewhat new company because Node-RED has been around for a long time. How long has it been around? It's got to have been many years.
So creators of Node-RED, I've known Nick kind of since when he was started creating it. And I was talking to him last week and said, I think it's kind of later on this month. it was 10 years from kind of later on this month when he first started working on Node-RED inside IBM. So and kind of Nick and Dave Conley Jones, another IBMer, were in an advanced technology lab inside IBM in the UK, and they really needed tools to help kind of do proof of concepts, do kind of innovative research projects, right? So they started building this tool out to do that. It wasn't open source at the time, right? But eventually they did open source it. I think kind of for 2 years it was in kind of a kind of incubated lab inside IBM, and then they open sourced it. So it's been around for a long time, right? And I think that's kind of a testament to the success of kind of Nick and Dave, right? They've really built up a very strong open source community around Node-RED. And so it's been a great success. And I think kind of in the IoT world, it's really well known for kind of making it really easy to connect different pieces of hardware, different kind of data services, and create kind of flows of information, often being sent to the cloud. So
Yeah, it's definitely grown in terms of popularity for home automation, but also in enterprise applications and things like that, right? You're
yeah,
seeing a lot of adoption in smart factory and all of that, all of those kinds of use cases too, right?
no, absolutely. So I think I think probably the two most prevalent use cases kind of we see is certainly home automation. So kind of do-it-yourself at home automation, where kind of people are putting Raspberry Pis, Arduino devices, kind of more advanced sensors in, and then they create kind of do the integration and create the flows using Node-RED to control the different devices they have in their house. So it's pretty exciting to see. But frankly, for more interesting for me, right, is really what we're seeing in the manufacturing and industrial automation industry, where kind of companies and individuals are using Node-RED out on the edge, but also in the cloud to really start to kind of bring in industrial data, so they can do analysis, they can do machine learning, they can visualize the data, and they're using Node-RED to do this. And so it's I think kind of if you look at the value and kind of the innovation in the manufacturing industry, it's really a lot of it's about the data and getting the data from really kind of legacy hardware, right? And so I think kind of the challenge in the manufacturing world is it's very heterogeneous. There's lots of different hardware platforms, different proprietary hardware platforms, often with proprietary protocols. So it's really hard to actually get data from these devices. And what Node-RED is being used for is basically people are putting in edge devices, so either a PLC or an edge gateway that basically will be able to either take a serial port or an analog port and kind of, or even just the proprietary protocol and bring it into Node-RED and kind of do the analysis, create data flows for that, and create visualization for it. So it's really cool to see.
Yeah, that's really exciting to see. And for those maybe who don't know much about Node-RED, we should explain it's a visual tool that's based on these kind of flows with nodes, right? And those nodes then you can connect in in a visual fashion to have an application flow. Any sort of thing, anything to add on top of that?
Yeah, well, and I think so. No, absolutely. So I think kind of one of the key advantages of Node-RED is there's this community of nodes. So I think that's over 4,800 different nodes have been created, and so if you kind of and you can access them from by using Node-RED and it's all open source. And where this really helps, where there's kind of if you need something to connect to a Modbus, which is an industrial protocol, or if you need something to connect to NC, right, there's going to be a node ready for that. So you don't actually have to go and create the nodes yourself. You're really just wiring together existing nodes that are out there. And so if you're not a developer, this is really powerful, right? Because you can start to now get data and visualize data without really writing much code, if code at all, right? It's really, as you said, Dan, it's a visual programming environment. So you're really kind of dragging and dropping these nodes onto a canvas, and then connecting them together, right? And when you connect them together, you kind of with forms and menus, you kind of say what to do based on what the node can handle. But I think that's really one of the advantages of Node-RED is that it's allowed kind of non-professional programmers to really start to create innovation and create solutions for their problems, right?
Yeah, yeah, and it's low code, but it's also very extensible, right? So
Yeah.
if you are a coder, you can actually, create interfaces in Node-RED and create your own nodes essentially.
Yeah,
for those.
and that's kind of often visual builders, GUI builders. That's often the knock against them, right? Is kind of you're stuck in this visual paradigm, right? But with Node-RED, it's really easy to drop into JavaScript, right, and create kind of JavaScript code to extend your flows, and I think that's kind of given the best of both worlds to this paradigm where kind of it's not a no code paradigm, it's a low code paradigm, and so you can kind of get things going with the visual kind of visual canvases, but when you hit kind of the limits of the visual programming paradigm, you can drop down into JavaScript. So
Yeah.
it runs on top of Node.js, right? So for people that are kind of know the JavaScript stack, so it's at the heart is Node.js.
That makes sense. So yeah, nodes are really Node.js.
Yeah.
Yeah. So what are people? What are some of these nodes? We're talking maybe a little abstractly, but some of these nodes can be protocols, right? Like MQTT, and you mentioned Modbus and things like that. But they can also be services, right? Like an InfluxDB service, or other things that connect to somewhere on the network, right?
Yeah, or it could be a weather service. There's a weather service. There's a Twitter service. And so there's there's different kind of data services, whether it's consuming data or storing data. So Influx, I'm sure there's a MongoDB one, right? There'd be different types of services that for data storage. But then there's also consuming data that's out there, right? There's actually, we just did a demo of tracking the International Space Station going across. So someone's wrote a service for tracking that. It's a live data feed that they have out, right? You can kind of use kind of as a node for tracking that, right? So, and that's, I think, really the powerful we used to talk a lot about the long tail of platforms, right? And I think that's really kind of the power of the Node-RED community is that there's a lot of innovation, a lot of creativity in the community of creating different types of nodes. So there's the kind of core, there's visualization nodes like a dashboarding node, graphing nodes. There's data storage nodes that are out there that we've gone through. There's data access, so the protocols, so OPC-UA, kind of in the industrial world, right? There's a lot of different protocols, and most of them will have nodes for that. And then there's kind of different types of services that they can plug into.
Yeah, and what's really interesting about that too is you can even set up flows that have user interaction, right? And so you could have web pages or graphs or things like that are actually interactive.
Right. Yeah. For sure. I think kind of when we talk about dashboarding, right? So kind of let's pick on Grafana, right? So kind of Grafana is great for dashboarding and visualization, but you can't actually interact with the data. That's my understanding. So it's very hard to do interactions with something like Grafana. But with something like Node-RED, you can actually create kind of a user experience with the data, where you can actually create triggers and interact with the data. So you're creating more robust user experience, quite frankly, with the flexibility of Node-RED.
Oh, that's pretty exciting. And one last thing I think about Node-RED is that so it can be run on different different types of machines and in different implementations and different places really in the network stack, right? Different. So you could have it running on an end device, an edge, device, or it could be like a gateway type device that Node-RED is running on, orchestrating other end devices, or it could be running in the cloud too. And are you seeing, that use case, kind of coming up more as actually running Node-RED in the cloud for applications?
Yeah, no, absolutely. And I think we're seeing more and more kind of an architecture of both, right? So you push Node-RED out to so for instance, the use case, you're monitoring a number of devices, a fleet of devices, where you've got a Node-RED flow out on each of the device to monitor the health of that device, whether it's kind of temperature sensors or motion sensors, or just looking at CPU memory usage, right? So you're kind of using Node-RED to collect that information. You're sending that to a Node-RED instance on the cloud that you've got a visualization kind of created to show the health of all your devices. And you can sort of trending information, right? And then you can also add interactions to that dashboard too. So I think we've absolutely seen kind of some really interesting architecture patterns kind of being developed around more sophisticated deployments of that. And I think this is where I'm just going to come back to a bit to FlowForge comes in. This is where FlowForge comes in, right? Where you've got multiple instances, and how do you manage those multiple instances of Node-RED, right? So how do you automatically deploy? Because you need to be thinking in terms of software development life cycles, right? So how do you kind of update if you have a fleet of 100 devices that all have the same Node-RED instance, and you need to do an update, even like a security update, right? How do you roll that out? How do you roll back any updates that you might want to kind of revert from, right? And this is really where FlowForge comes in for that. And then, but again, on kind of at the cloud level, right? How do you kind of, if you got an instance that you want to deploy in the cloud, right? How do you go from a development instance to a test instance to a production instance? And these are the tools that we're offering with FlowForge to make it much easier to kind of think in terms of a DevOps mentality that IT people really start to expect now when they're talking about large-scale deployments.
Yeah, I think we had a conversation in that vein last week with our guest Mark on DevOps for IoT, and this seems to be kind of an interesting trend that we're seeing more of is DevOps type type flows coming to IoT and really as a leverage point for IoT implementations.
Well, I think like certainly kind of in the industrial world, I really find the industrial world is very hardware centric, right? And if you talk to someone in a factory floor, it's all about the hardware, right? Kind of they think in terms of PLCs, kind of sensors, their factory equipment, right? They're there about the hardware. But as you start to introduce IoT digitalization into the factory, that's all about software, right? And so I think there's going to be a meeting of kind of the different cultures of the OT and IT culture, and introducing more software-oriented tooling into the OT. I think it's going to be really important to have the reliability, the kind of the scalability that you would expect in more of a software-intensive operation. And that's really where DevOps kind of it comes in.
Yeah, I like that. Nina, did you have something?
No, yeah, this is a really interesting topic. Is like, we have in IoT now, and we talked about this, like nobody buys IoT and so forth, but we have like different personas and different expertise that need to deliver a project that has connectivity to the internet. And then how do you, as you say, this OT, IT, how do you make infrastructure for them so that the actual people who need to do something in order to kind of get insights or whatever, can do that quickly and easily and iterate faster, right? Yeah. So this is a problem across the board. Like if you look at it from the automotive perspective, the industrial or consumer electronics, it's basically kind of like the same issue, but then different tooling will be used for different use cases, I guess, for different personas.
No, absolutely right. And I think kind of, and like if you kind of read anything about kind of digitalization projects in kind of manufacturing, there's always this cultural clash between OT and IT. And it comes because they think very differently, right? Like kind of, if you're working on a factory floor, downtime is paramount. Like kind of minimizing downtime is all that matters, right? Safety would be probably the highest priority, but downtime is the close second, right? Right. So they can be very conservative on kind of what they let in, what the changes they do, right? Because if the plant goes down, like the kind of, you can be losing millions of dollars a day or a minute, right? Depending on what you're producing, right? So that's kind of creates a culture and a mindset that will drive decision making into an organization. On the IT side, like kind of IT is much more fast moving, agile programming, right? Kind of iterations, kind of quick to change, roll back, right? Things like that. So there's often this cultural clash that goes on. But when it comes down to it, kind of the organization needs to get this industrial data kind of out of the factory and kind of to get the value that they're looking for to kind of modernize their infrastructure, right? So, and in my experience, when the successful projects really is when they have kind of really strong OT people and IT people working together. Because the IT people don't actually understand the data that's coming off the equipment, right? That's very much kind of what a manufacturing or automation engineer does. Like they know the data, right? And so they need to be in the loop on kind of what to interpret data, how to get the data, get at the data, and how to interpret the data, right? The IT people kind of, they know how to run databases. They know how to run analytic tools and things like that. So there needs to be an environment to bring people together. What often kind of, and this is where Node-RED starts to help out, right? Is, excuse me. Sorry, my house gets a bit dry in the wintertime, so
yeah.
So 1 second.
Yeah, no worries.
Yes, so they need to kind of bring it together, but where Node-RED actually starts to help, right, is that, and this is where kind of we see a lot of manufacturing and industrial automation engineers will be using Node-RED to kind of start the discovery process of what this data is all about and how to collect the data, right? And that's really powerful because they actually don't need to rely upon a developer to actually kind of do the coding for them. They can actually do it themselves, right? And get the innovation, get the value out of it almost immediately. And then the IT people can actually start to supplement that by helping to scale it up. So, but Nenad, I think it's I've always thought kind of IoT projects are probably some of the hardest projects to kind of organize and deploy because you have to include so many different skill sets to make it successful, right? and I think the good news is I think people are figuring it out, right? It's taken a long time for us to get there.
Yeah, definitely. We had a bunch of discussions in this regards. Is like, how to bring those people with different skill set and kind of organize them to kind of work on a same project and understand each other, right? This has been a critical component we've seen so far. So
Yeah.
definitely agree on that.
Yeah, and so speaking of industrial, there's there's kind of this um, nomenclature thing around industrial where people are using terms like, or we're using terms like Industry 4.0. Now it seems to be IIoT. We've heard smart factory, digital factory, all these kinds of terms being thrown around. What terminology do you kind of gravitate towards, or what do you think is kind of the the way to
Yeah.
think about
Yeah.
the way to think about all of this? Because in a way, it's a little bit of
Hodgepodge. Yeah.
buzzword soup, right?
Yeah, exactly. So I probably intermix them kind of. I typically don't kind of worry too much about it. But I think kind of traditionally what I've seen is Industry 4.0 is a European term. It came out of Germany. So you typically see that used more in Europe and certainly in Germany. IoT or smart manufacturing is more used, in my experience, more used in the US. But I think for me, I think these are really industry terms. Kind of when you go and talk to people in a plant, I've never heard of anyone say, "Oh yeah, I'm doing an Industry 4.0 project." Right? Right. So they will often talk about they're kind of doing a digital factory, a connected factory, or they're working on a digitalization project. Right. And I think I'm a big. I actually think the whole IoT term will eventually kind of fade away, right? Because the things that we're talking about, right, are really going to become, and they are becoming very much the fabric of the IT stack, right? Right. And so as that happens, you're not going to be there's not going to be a special IoT team anymore, right? It's just going to be assumed that you're connecting your devices in and the data is coming in. Right, and we still have ways to go. I used to Gartner did a kind of a quote that I loved using kind of in the previous job that I had, but they're saying that I won't get the numbers exactly right, but the percentage of the data in a data center, right? So today, kind of 75% of the data is created within the data center. So like ERP systems, CRM systems, e-commerce systems, like those are data that's data created kind of in 2025, but kind of Gartner makes up their numbers. But they were saying, and I think this is absolutely true, that by 2025, they're saying like 80% of the data was going to be created outside of the data center. Right.
Oh, interesting. So it's
right,
kind of a pivot point, right? Where
right,
so much data is being created within the data center to, data input and all that kind of thing. Now we're actually going to be bringing in all of this outside data. Wow.
Right. So data comes from products, like from connected cars, from connected medical devices, and into an organization. Data comes from factories, right? That's never been coming into the data center, right? So there's going to be this huge change going on, right? But when that change kind of solidifies, right, then it just becomes part of your operation, your technology stack, your technology operation, right? And then when that happens, then I don't think actually IoT becomes overly useful as a term. Right? So,
yeah, that's a fascinating concept, because then the whole world is your data center.
yeah, exactly. Yeah. Right. So, for sure.
Yeah, in that regards, it's also interesting. I mean, now it's like people talking about edge computing and all that stuff, but it's also interesting to look at this from that perspective in terms of like you would need to have processing where you actually need some reaction, right? And and it's like, yeah, the data centers are going to be taught as like something that is collecting this data in huge amounts and then processing it, but it's a slow process. And then when you move out the data center, you have like faster reaction times, and you have applications that are processing quicker and quicker this information and then acting upon it quicker and quicker. So yeah, this is still, I mean, we see bits and pieces of that with so-called edge computing and so forth, but yeah, it's not there. I mean, especially when you think about that infrastructure that needs to be built in order to allow like all of this to have application exactly, to have application that operates on data exactly where it's needed and not have it somewhere like randomly in the stack. Yeah.
No. So, but so I actually think we're further along for edge computing. So, edge computing is kind of one of those terms that you have to define. You can define edge computing means different things to different people based on your perspective, right?
Yes.
Right. So, and there's kind of different. So, a 5G, like if you ask a telco, right, they'll say a 5G network is edge computing, right? And
yeah, I was
from their
about to say that. Yeah.
Yeah, there it is, right? They got their MECs, right? They kind of you can run kind of compute in the at the kind of in their network, right? So that's their definition of the edge of the network. If you talk to a global manufacturer, right, they will have each factory be kind of an edge of their overall network, right? So each factory will be an edge, and they'll consolidate, aggregate data into a data center, a corporate data center, right? Within a factory, right, there will be each equipment line will be an edge. Within each equipment line, there'll be kind of multiple PLCs that could be collecting edge compute, right? So, and this is where the complication comes in, where kind of how you percolate the data up through that, right? But you're absolutely right. Kind of to me, edge computing is all about lower latency and autonomous computing, right? Because if you don't have access to the internet, or if your network's down, you can't bring your factory down, right?
Yeah.
Right. So those are two, and then there's the privacy and security concerns too that edge computing helps with, right? But I actually think there's been some really good progress around there. One of the things I think has changed in the manufacturing world over the last kind of 3 to 5 years is kind of 5 years ago, at least 50%, if not 75% of manufacturing companies would never say they would send factory data to the cloud.
Yeah.
Right. And I'm sure you've probably heard this.
In Germany, we hear that a lot. Yeah.
Yeah. Right. But I think that's changed considerably now. Right. Like I think it's people are kind of realizing that yes, this is there's a lot of value of doing that, right? And so I think this is where kind of edge and cloud computing can be kind of done really effectively in combination, right? And certainly, I think kind of AWS IoT is certainly on the forefront there, with kind of what you guys have been providing. But because I think kind of if you want to do things like advanced machine learning, right, you're not going to do that. You're not going to create a model kind of at the edge, right? You push out a model to the edge, but you're going to do the number crunching kind of at the cloud. You have to get the data in there to kind of create the models, right? For that, and trending across different facilities, right? You need to get that information in the cloud to get it into kind of CRM systems, supply chain systems, right? You need to get that into the cloud, right? So I think both absolutely exist and will always exist.
Yeah, and interestingly, you mentioned like industrial, but if you look at, for example, car and the automotive industry, it's more or less the same concept, right? So I mean, AWS has two products. Like one is the AWS IoT Sitewise, and another one is AWS IoT Fleetwise, and but they operate kind of the same. It's like you put them in the edge, and then they are more or less collecting this data, of course, with different protocols, with different tooling and so forth. So that this is what I was mentioning earlier, is like this kind of methodology is across whenever there needs to be connectivity. But yeah, as you said, like in industrial, it's quite
Yeah.
you can see it and touch it, and it's quite useful, I would say, rather than the other industries. But it's kind
Yeah.
of similar.
Like I think there's some differences in terms of network connectivity. So if a car is moving around, there's kind of maintaining connectivity and doing the data communication is different from if you're in a factory and you've got a pretty stable network connection. So there's different architectures that you have to put in place, and but I absolutely agree. Kind of in general, there's very similar use cases.
Yeah, and we had this situation. I'm coming back to industrial. We had the situation where actually we were going down the shop floor. We're connecting to the network, so getting access to the PLC and the data and OPC UA and all that stuff. But then they said we could not connect, for example, to their main network. So we had to use like 4G, 5G. So in that scenario, it's kind of the similar as well, right? So you have that kind of like low latency communication via networking and so forth, but then you have an intermittent communication to the internet as well. So
they'll they'll set up pretty advanced DMZs to kind of tunnel the data through to get it out, right? Yeah, so it's but again, like kind of it comes back to, right, what are these factories doing, right? And so like if, for instance, if it's a chemical factory, right, you really want to make sure no one gets in, no bad actors get access to the OT systems of the chemical factory, right? So you can kind of understand why they put pretty high barriers to entry for that, right? Right. So there kind of some of this makes sense. Some of it I think is just old fashioned thinking, right? But again, it's always on use case, kind of depend on the use case.
Sorry, we derailed this conversation, but I kind of like this trends and so forth, how things are going. I don't know. So I think what we did talk before was about this Linux Foundation survey. I don't know, Dan, you mentioned this earlier.
Oh yeah. Talking about trends. One really useful survey that we see that happens every year is this Eclipse Foundation IoT survey. And as it turns out, Ian, you started this a number of years back, right?
Yeah. So I used to work at the Eclipse Foundation. I started the Eclipse IoT community. And so this is kind of when we first started it, we kind of, MQTT was basically one of the first projects that we brought in, the MQTT, the Power project. So basically we started, I think when we started the survey, but I'm pretty sure it's been running at least eight years now.
Wow. Yeah.
And but yeah, so when kind of really with open source, we can kind of certainly talk about a bit about open source, but kind of when you work in an open source community, it's always hard to understand. You don't have a customer list, right? So how do you understand what they're actually doing, right? And kind of what they're using, kind of what's important to them, right? So that's really why I wanted to start the surveys, to kind of get a better idea of kind of what the community was doing, what kind of, as we said, like IoT is very complex. There's many parts of the stack that you need to do. So what are the different parts of the stack that people were using, right? So that's why we started, and they kept on. I left the foundation 5 or 6 years ago, but they've kept on doing it. So I think it's a great asset for the IoT community.
Yeah, and it's really interesting too. It's fairly broad in terms of the topics that are being tracked and some of the data there. From edge systems to cloud infrastructure to operating systems, everything.
Yeah, like we really kind of, when we put it together, we kind of thought in terms of there's kind of the sensor, the edge, and the cloud, right? And so what's the stack that people use on each of those three tiers, right? So we're certainly interested in kind of from a cloud perspective, kind of who are the kind of the key vendors there, and kind of certainly AWS was always in the top two there. But then when you're on then we're asking about what language people are using. So Eclipse is very Java-centric kind of community. So Java would always be kind of highly represented, but JavaScript and Python were also kind of well represented. But then kind of what operating systems, and we actually, for a while, I'm not sure if they still do, we're asking what chipsets were people were using kind of out at the edge. So it was pretty good. But certainly kind of in operating systems, things like kind of Ubuntu and Raspbian, right, were certainly prevalent and dominant.
Yeah, I really like the just all of the insights in these surveys.
Yep.
Yeah. Any let's see, any interesting trends that you see coming out that may be surprising, or at least I mean, you mentioned the the data center pivot that's maybe happening, but any other interesting things you see in IoT trends or so forth?
Yeah, I was thinking. Sorry, I think we covered so I think we talked about kind of the OT/IT trend quite a bit. So
Yeah.
but I think that's a really important trend that needs to continue. And it's probably not. There's certainly technology that needs to be kind of to help with it, but there's also cultural. I think in terms of the importance of the cloud and edge, we've kind of gone through. But I think kind of edge computing's first kind of became a thing probably about 5 years ago. And it's definitely kind of, I think that type of architecture is really what's kind of helped gel and made IoT more realistic for people, right? Because I think kind of trying to send all the data to the cloud, right, just really wasn't realistic for bandwidth, for just kind of, there's just a whole bunch of issues with that. So I think the kind of edge computing is definitely will help there. I think in terms of, we mentioned 5G. I think that is, it's like there's a lot of marketing hype around 5G. I think it'll be interesting to see how that gets rolled out. I know the automobile kind of for safer cities, safer roads, right? Having cars and people connected with 5G to kind of reduce traffic accidents was one of the major use cases I saw when 5G was coming out. So it'd be interesting to see how there's huge kind of hurdles to get to that point, or certainly from the infrastructure. But I think that would be interesting to see. 5G was also kind of pushed into kind of manufacturing, which frankly I've not seen much of, right, in adoption for 5G in manufacturing, kind of inside factories, kind of private 5G networks, for instance. But that's not to say it won't come. But I think it will be interesting to see where 5G takes us. So, but like certainly things like machine learning and analytics, right, is, I think there's a long ways to go there. But I'm sure. I know AWS has lots of smart people working in that area too. So I'm sure they'll come along. But I think because it's really about the data, right? Kind of IoT is about data, and getting data and getting useful data, turning data into useful data and useful information. And so it's really that's really what it's all about.
So I got a question, Ian. I used Flowforce lately, but I have used Node-RED in the past. I mean, I have seen in the new Flowforce environment where you have something such as devices. When we are talking about devices, are we actually talking about Node-RED application running on edge devices and you picking up the devices to show on the Flowforge? as the individual device, or you're basically looking at these edge devices and each individual application is running as part of the Node-RED within the device?
It's I think it's the former. It's first. Basically, it's you're deploying Node-RED out to a fleet of devices, right? So so you create a Node-RED flow, and then you want to run it on a PLC, or you run it on the same kind. You've got PLCs throughout your factory, right? And you want to run the same Node-RED flow on each of the PLCs, right? So how do you deploy that out in an automated fashion? How do you update it in an automated fashion? How do you track the health of each device? So that's really kind of the concept of device and FlowForge.
I see. Okay.
But you can also, I mean, you can also like have the deployment in a cloud as well, right? Where you aggregate this data and you have set of data that's like coming into the cloud. And you can also, have a Node-RED that's taking this data, operating on it, and creating some new insights, right? So
absolutely, so that's I think that's the power of Node-RED. From a marketing point of view, it's the challenge of Node-RED to make sure we communicate it effectively for both, right? But yeah, no, absolutely.
Are you? We talked about edge quite a bit here. I mean, from Node-RED perspective, and obviously, when I've used Node-RED in the past, it was effectively event-driven. Are we able to do any sort of compute actions on these edge devices by utilizing the orchestration of FlowForge, and then have that data streamlined and send it to AWS IoT Cloud?
Yeah, for sure. So I think kind of the FlowForge doesn't really have orchestration, so it would be Node-RED orchestration. But kind of, and this is where you probably would drop down into something like JavaScript if you wanted to do some more advanced compute in Node-RED, right? It depending on kind of what you wanted to do, right? But absolutely, kind of, I think what Node-RED kind of by default uses MQTT to kind of transmit data, right? So lots of people will use kind of basically set kind of AWS IoT up as their MQTT broker, right? And just forward it to kind of having Node-RED send it into AWS IoT.
One thing about Node-RED, and I can't say I'm really familiar with Node-RED, so I haven't used it. I read about it, but out of curiosity, how much would Node-RED be actually used for device management workflows as well? So here I'm thinking more of a combination of workflows that run in the cloud and workflows that run on the devices, and this sort of orchestration both on the cloud and on the devices, and getting this aggregate insights into the performance of the workflow. I'm thinking in terms of, for example, firmware upgrades.
Yes, so Node-RED's really at the application level, right? So so Node-RED itself doesn't do the device management. That's really FlowForge built on top of Node-RED. But that's not to say you can create an application that a Node-RED instance running on an edge device or multiple edge devices can communicate with a Node-RED running on the cloud, right? Now, how you manage that, right, is not in Node-RED. You could use something like FlowForge to manage the deployment of that, if that makes sense. I mean,
no, it makes total sense.
Okay.
Cool. So I think we said we'd talk a little bit about open source, and you've been involved in open source now in a few different ways. And I think what do you see as some of the winning ingredients, I guess, for open source? Node-RED is clearly a successful open source project. what do you think has contributed to that?
So I think I'm a big believer in technology gets adopted bottoms up, right? So in organizations, there's always smart developers, smart technologists that are out there scanning for tools, new technology that it's going to help them be more productive, more efficient, and help their organization be more successful and kind of help them solve organizational issues, right? And these are the people that are out there kind of looking for things. And the way they find things is through Google search, typically, right? And when they do find something, they want to evaluate it, right? They want to touch it, they want to feel it, they want to use it, and this is what open source allows them to do, right? They are kind of open source makes it really easy. There's no barriers to entry, right? As opposed to commercial software that basically even if there's a free trial, sometimes you have to sign a license agreement, or there's just a short-term license, a free trial for it, right? So open source I think really lowers the barriers to adoption for new technology. And I think that Node-RED is definitely a benefit from that. And then the flip side is around the community, right? If you're, it's a lot easier to get multiple vendors, multiple organizations working together on a common platform if no one vendor controls it, right? And so you can get OPC UA nodes created, you can get Modbus created, you can get Siemens S7, you can get Schneider Electric nodes created, all for Node-RED, because no one vendor creates or kind of controls Node-RED. So it's easier to kind of get this platform effect going, where you have lots of connection and integrations with the platform if it's open source. So I think those are kind of the two primary drivers of kind of open source in terms of technology adoption. And then so it makes it really easy for people to adopt it into our organization and get the value, because there's so many integrations available to really optimize the value of using that platform.
Yeah, I like that. I think you've said too. It's nice when developers can try things without having to ask for permission.
Yeah.
I like that.
Yeah, no, for sure. Like it's because, and actually, we kind of you see this in surveys of developers, right? Kind of they will learn new technology in their free time typically, right? So they're on the weekends and the evenings. Kind of good technologists are out there learning about new things, kind of trying things out, and it's usually in the free time, right? And so they don't want to actually have to ask for permission to do this, right? This is kind of what they love to do, right? And so you need to kind of make it as easy for them to do it as possible.
Yeah, and I also like what you said, this like no control. I think this is really important as well from the open source perspective, is that the governance of the open source project should be community based, rather than something that's owned by a specific company, and then they have the say, and then they can just shut it down if they want, right? I think this is something where, when it comes to investing into the future, and as you said, developers picking up technology, they will always lean into this kind of like community driven open source project. Of course it can be backed up by companies, that has to be at some point, but that's a good point for me as well.
Yeah, no, for sure, right? Like, so for instance, for back to Node-RED, like actually I'm actually kind of working on blog posts around PLC vendors kind of supporting Node-RED. I think there's at least 16 different vendors kind of with kind of supporting Node-RED on their PLCs, right? If Node-RED wasn't open source, right, the PLC vendors are not going to invest in another vendor's software platform for their platform, right? Because as you pointed out, right, kind of the government's the control, right? If I'm Schneider Electric and I'm going to go and kind of support S7, Siemens S7, right? Well, Siemens can just say no, right? Right? Kind of they can say, well, we're not going to kind of allow you to do that, right? With open source, right, it's kind of it's no one has the control for stuff like that.
Yeah, perfect.
Okay, well, let's see. We, as always, we are approaching the top of the hour rather quickly, and yeah. If let's see, do you have anything you'd like to add, Ian, before we start winding things down, or are there any other last minute comments or questions from the group?
I've definitely enjoyed the conversation. I think it's exciting times in the space. I think I've been kind of doing IoT since 2012, 2013. So
Wow.
coming out 10 years. And to me, there's still a lot to be done, but companies are getting real value out of using the technologies that we've been talking about. And I think that's really kind of great to see, and it makes me feel good that kind of there's real value being generated out of this. And certainly, I think kind of AWS IoT is certainly an important part of that equation, right? Having kind of really great, strong cloud service available for that. But it's a huge community, right? There's, like as we've said, there's many different vendors needed to be successful for an IoT project, right? It's kind of making sure kind of the open source, the open protocols are in place to do that is I think key.
That's really great. Yeah, great insight there. I think you're absolutely right. Well, thanks a lot for joining our IoT Builders live stream. Much appreciated, and it was great talking with you. And
Absolutely.
yeah, okay. Um,
Thank you all.
yeah, and thanks Nanad, thanks Alina, thanks Syed. We'll be back again next week. But until then, so long.